we shouldn't be too rushed for this meeting, so we'll wait another minute or two. So, David, do you think we're okay to start? We can't hear you, David. Are you muted?
Hey, Bernard, this is Alan. Not only is David muted, he is also under a cloak of invisibility, as we cannot see him at the front of the room.
Ah, okay. Well, how about this, Alan? Would you be willing to sit up at the front just for the sake of being the...
I heard Mock has chocolate for volunteers. I'm just kidding.
Oh, okay.
Yes. Yeah. Yes, I can do it.
Okay, thank you. All right. So we'll, yeah. All right. Thank you very much, Alan. And okay, just a few meeting tips. Hopefully everyone has gotten used to using Meet Echo by now. And we're going to use it for the mic queue. So please take note of that. And if you're not speaking, please keep your audio and video off. We still have the mask mandates in place, so please wear those unless you're actively speaking at the microphone. And if you're remote, we urge use of a headset or a echo canceling speakerphone. So just a few reminders on how Meet Echo works. To enter the queue, there's this hand tool. You click on the hand with a slash. That puts you in the queue. And then we call on you, and you enable your audio or video, and then you leave. When you're done, you poke it again, and that takes you out of the queue. Please don't speak without getting in the queue so we can manage the queue in an orderly way. And of course, video is separate from audio. You don't have to enable a video if you don't want to. Although, of course, if you're at the mic, we're going to see you. But if you're remote, that's up to you. Okay, so here's some info about IETF116. And the agenda is up. An accurate agenda is up on the materials site. And if you're having any technical issues, there's a link that tells you how to report them. Hopefully, everything's working okay. So here's the note well. You've no doubt seen this at this meeting, previous meetings, but it's basically a reminder of IETF policies that are in effect on topics like patents, code of conduct, and by participating, you agree to follow these processes and policies. And in particular, if you're aware that there's a contribution that's covered by patents or patent applications, you must disclose that fact or not participate in the discussion. Here we are, David. No rush. We're just in the note well. And if you want more detailed info, we have pages and pages and pages of BCPs that you could read. But please don't do so now. You'll probably fall asleep. Then we also have a a guideline for conduct, an anti-harassment policy, and anti-harassment procedures. So if you have any concerns about that, talk to the Ombuds team. But we hope that we maintain an environment in which we treat people with dignity, decency, and respect. But if not, please talk to the Ombuds persons.
And also feel free to talk to your chairs. We're happy to take anything. Luckily, we haven't had problems in this working group because everyone's able to be nice and friendly.
Yep, that's cool. We have the mask policy is in effect. I'm sure you're used to this by now, but it must be worn in the meeting rooms and are recommended for common areas. You can remove it for eating and drinking, and also active speakers can remove their mask, but otherwise no exemptions. And we're asking for N95s, FFP2s or better. And there's a link that tells you all the details. All right. So a little bit about this meeting. The agenda's up there. There is notes up there. We would like you, once we find who's going to take notes, please take them in the note app, and the link is there. And so we get to the part of the meeting where we're going to beg for note takers, or maybe not, if someone volunteers quickly. There's someone out there who wants to volunteer to take notes.
This is a part where I stare awkwardly into the audience and notice that everyone is staring intently at their laptop. Come on,
Exactly.
folks, taking minutes is really easy.
That will not exempt you, though. The chairs see all.
Yeah, Bernard's actually in the ceiling.
Yeah. So do we have to go and harass people? I think we've reached that stage. David, do you want to pick a victim?
Nidhi, thank you. Much appreciated.
Okay, thank you very much. That is much appreciated. Okay. All right, so here's the agenda. It's a lot like previous agendas. We'll have a W3C update from Will Law. I think it's Will. And then we'll talk about web transport over HTTP 2 and then web transport over HTTP 3, and then do the wrap up and summary. All right, so W3C update. Will or Jan or Jana?
Test, test. Okay, that's better. So thank you. Good afternoon. My name is Will Law from Akamai. I co-chair the W3C Web Transport Working Group along with Yanivar Brewery from Mozilla. So we're going to give a short update on progress over the W3C. Our status is working draft still. We've updated it. The last one was published March 14th, just a few weeks ago. And it's current on the website. The links are available there. Our charter was extended for an additional year. It did expire last December, and it's been renewed until December 31st of 2023. We've set a rough timetable for the year. This is perhaps aspirational. We're hoping to get to a proposed recommendation by September. There are not too many large issues outstanding. We have a milestone, which is called candidate recommendations. We've got 19 open issues, but 18 of them are labeled ready for PR. So if we can get those down, I think we're in a good position to achieve the timetable shown here. And I also want to welcome Nidhi Jaju from Google, who's a new editor for the specification. Is that the same Nidhi who's taking notes? Okay. Hey, good to meet you in person, actually. I've never seen you before. Okay, a summary of some of the major updates that we've had since our last IETF report, which was back on November 10th. So firstly, web transport send stream and receive stream, make them transferable. You can now send them over to workers. This is actually restoring an older behavior that got broken. You can open streams in parallel to the connect request. So you do not have to wait for the connect to complete before you can go ahead and say, create a unidirectional stream. You can ask for the connect, create the stream, and it will get queued up and execute immediately. Send order and stream creation, we added a 2 to the 64th send order integer. It has a nullable state right now. Higher the send order, the higher the priority that the queues get drained on the sending side. In speaking to Victor, there's two issues you'd like to resolve. One is that it's not applying to BiDi streams, I believe, the API, we need to fix that. And the second is you would like to make a send order of 0 to be the default instead of null. I'm actually writing the issue. He's writing the issue right now, so it's the latest information. Thanks to Bernard, we've got a web codecs echo in the samples directory, so you can grab the code and start playing around. Web transport error adjusted slightly. This is a change for Chrome because they went early. We're basically aligning with W3C guidance for the constructor signature, and we have a code sample shown here. WT draining promise will now resolve once the web transport session receives either a drain web transport session capsule or the go away frame. And so your application now gets notified that draining is active. And then lastly, BYOB readers for datagrams. Applications supply its own buffer for a single datagram, and there's a recommendation of a max buffer size of 64 kilobytes. Next page, please.
Yeah, just one thing I wanted to say, Will, is we're only supporting on the client receiving go away and drain web transport. At least at the moment, we don't support sending it. And so if people feel it's important to send it, I guess they should pipe up.
I think I have a slide coming up on that, Bernard. But thank you.
Okay, cool.
Yeah. So update number 3 is Firefox have released web transport support. Now, is Randall on the line or Yanivar, either one? I was going to give them a chance to speak to this.
Hello.
Yes.
I'm Randall.
Hey, Randall.
Hello.
Would you like to present this slide since it's your work?
Sure. Firefox 113 nightly supports web transport. The pref on by default for nightly is literally building as we speak here. It merged to central a few hours ago. This includes datagram support. Congestion control is cubic. It's largely written in Rust, and we passes almost all of the web platform tests, and we've added several in the process as well. And the last few we'll be getting to very shortly. There's a few features that we haven't landed yet, like send order support and outgrowing datagram timeouts and a few other details around that. And BYOB readers for datagrams, since I implemented the spec before we added BYOB readers for datagrams. So I'll have to update that and some other small details. And if you take the current nightly and make sure you've updated it, and if it's not the one that's building at this moment, turn on the enables for web transport. You can go to moq.streaming.university and see that it works just fine. So that's basically it. Have fun. File bugs.
Thank you very much, Randall. And it's great to have 2 working versions now. So we can start to look at interop as being one of the next items there. And then I just wanted to present some of the current issues of debate within the group. And if there's any feedback or guidance from this group as per the direction, then we welcome and appreciate it. Firstly, we're debating adding a send rate estimate to our webtransport.getStats method. This is an estimate of the maximum rate at which the application can write data and avoid queues building up. And we have a lot of questions on this, which I won't read them verbatim because you can. But it's a stat that is easy to get different implementations from different user agents. Whether it's nullable or not is an issue of debate right now. And is the value going to change as you're sending? So if there's guidance from this group or any experience in implementing such an API, we'd appreciate it. Bernard, should I pause for questions after each issue, or I think it's more relevant. Otherwise, we've got to multiplex our questions.
Yeah,
Eric just do.
If people are in the queue, you can call on them, Eric.
Yep. I can't see the web queue though. I can only see the room queue.
Yeah, Eric, you're.
Oh, okay. I can now.
Helps if we turn the microphones on. Eric Kinnear from Apple. So I think this is one of those where it's kind of hard because there's all these interesting questions, and that makes it a slightly harder problem to solve, and it's tempting to just try to kind of punt that. But as we've seen a whole bunch of people who are trying to use web transport, especially for media-related applications, I think this kind of feedback is one answer to the give us essentially a UDP packet and we want to build the same thing all over again. And so it's really tempting to try to actually solve these rather than just punt on it. So yeah, we can quibble about spelling it and making it nullable or not nullable and all of those things. But I think the overall question is it worth spending our time on? And I think the answer is yes. So, and I think we should do it and update it over time, and we can answer all those fun questions.
Online. Okay, thank you.
Kenichi?
Yeah, Kenichi Shibashi, Google. So this is kind of a question for Randall. So about the implementation of the Firefox. So which HTTP3 datagram version you are implementing? So we currently implement, so Chrome's implementation based on the draft 04 of HTTP datagram, but we are going to change that to the RBC version. So yeah, I'm wondering what version you are using.
I'll be honest with you, and I do not know. The datagram code was implemented, the network side datagram code was implemented by another engineer here. I'm happy to check on that for you. So feel free to send me an email, rjessup@mozilla.com, and I'll happily hook you up.
Thank you.
David?
Yep. David Skenazy speaking as a datagram enthusiast. I might know the answer here because MT was telling me that Firefox almost has the datagrams, but not quite yet. So the answer is neither, but I think they're almost there was what he was saying. May I ask that you CC the list on that email because I think we'll all be curious. And I wanted to also apologize to everyone. It was my fault from the mask side that it took a while to get to the RFC version of datagrams, but we're there now at least. And like, if let's make sure that we have the same versions in Firefox and Chrome, so that it makes it encourages websites to just do one thing and not start user agent sniffing.
Thank you, David.
Okay, queue's empty. I'll move to the next issue of debate, which is client-initiated drain. And this is what Bernard just mentioned. So we have notification to the browser client that the server is initiated draining. But the quest, if you read, and I quoted here from the web transport spec, either endpoint can send a drain web transport session capsule. So the question is, should we allow the JavaScript application and API to send a drain notification to the server? And we gave an example of a client archiver app that might not want to lose streams in flight if it was terminating its connection. We don't know if that's valid, but we appreciate some input from this group as to whether we should expose that API to a JavaScript application.
Yeah, Alan, do you have an opinion on this? Also, Eric, go ahead.
There's a queue. You guys go first.
Hey, Lucas Pardy, Cloudflare. I would rephrase the question as, is there a reason not to provide one? So,
generally, the less APIs we provide applications to hang themselves, the better. So that would be the reason. But in this case, there seems a valid use case.
What Alan had pointed out, and I guess, Alan, you can speak to this, is the danger of doing this in the case where you're doing frame per stream transport, because essentially, in that case, if you're saying don't create new streams, you're basically saying don't send anything. So that might not be what you want necessarily. Anyway, Eric?
Interesting. Eric Kinnear. So I was going to say this kind of comes back to one of the debates that we were having in HTTP land around, if I send a FIN while I'm in the middle of receiving something from a server, should the server continue to send it to me or not? And the ambiguity there means that we've essentially had to just say, that's kind of how people treat it, even if that's not really what we wanted. So the temptation from a specification standpoint, I think is, yes, please expose this. Let's have that kind of explicit signal so that we aren't later left guessing about what did the clients really mean, and half the people use it this way and half of them use it that way, so we have to do the most restrictive thing because we don't have a better answer. And I think that specificity is probably more important than keeping it as small and less foot gunny as possible, but that I could go either way on that one. Yeah.
Alan Frindell. I am a client-initiated go-away enthusiast. Although my the main reason why I wanted this, originally I pushed for it in HTTP3 and then also pushed for it in web transport, has more to do with proxies that are going like that need to shut that are acting both as a client and a server and want to send that capsule in both directions essentially, rather than thinking about a client-specific case. Although I think you have a perfectly good example here of why a client might want to send it. And I echo Lucas's point, like, why not? I'm not sure it's that big a foot gun. The text in the IETF draft says, just, you know, it's sort of fuzzy, right? Terminate the session as soon as possible. It's sort of application dependent what that means. And the web transport application running server side, well, you know, if you're doing frame per stream, like maybe it'll just terminate abruptly in the middle of something, or maybe it'll know like I'm in the middle, I'm going to go to the end of the next logical stopping point. It's just an indicator. So I don't know. I don't think there's that much risk that people are going to.
So the use case, Alan, would be like a mock relay or something like that you're sending it to, and you're expecting it'll forward it on to the subscribers.
Well, the reason why I want it in the web transport draft is more like that relay is going away and it wants to notify both endpoints. Like I'm going away. Like you guys figure it out, what you want to do. So when the idea of draining a server with go away, it's not just like one direction, like server going away, client needs to know. Sometimes you want to forward that so towards whoever's generating the data. Thanks.
Thank you. So queue is empty. Can we go to our last slide for the W3C update? Okay. Okay, the next item, a max stream limit. So there's a default limit built in, I think, to save memory was the reason for, to protect the stack on either side. And as we start doing frame per stream at 50, 60 frames per second, we're very quickly going to get over this limit. So the question is, do we need an API at the JavaScript level to request that the user agent increase the number of allowable incoming streams? Or should the browser automatically handle this in the background and the application just opens streams as it wants and the browser takes care of it?
Lucas?
Hey, Lucas Pardew. Speaking from somebody who has an implementation that does stream limits, not for web transport, but just for quick, that the API is really, really simple. It is configurable, but it's not dynamic and responsive as much as pick a number and that's the highest thing. But we want to improve that. We want to come up with min watermark, like max watermark levels, some ability to do stuff, maybe make it literally dynamic so that you keep asking or granting more credits. Like, I think you probably don't want the auto magic thing, but what the shape of the API is, I think, is going to maybe take some iteration on. So that's not maybe good input, but
so you see it as more of a hint to the user agent to then do something, to give it a hint that I am going to be opening up streams at a certain rate, or I expect this count of streams in flight.
Yeah, I don't know. I think if you don't if there's no configuration and it's magic and it's opaque and it's different between implementations, like it's just going to cause pain for users, in my opinion. Like, true, you might not hit it day to day. You know, we see this in HTTP. It's like, okay, well, you can make 100 concurrent requests. In most cases, that's never hit. But then when you do, it's not game over, but it's awful. It's terrible. And what can you do then? Wait for the next browser update to ship, or wait for a new spec? Like, I don't know. So I would like to see maybe a candidate API of how that might look, and then maybe give that some review.
Sounds good. Thank you.
Randall?
I mean, if the downside of hitting this can be very bad, as was just mentioned. How much are we saving by making, having the limit there? What are we, are implementations really using fixed size tables for this? And if they are, let's set the limit high enough that it's relatively safe for almost any conceivable application, unless I don't see why it would be using that much memory in there, and I don't think that our implementation does.
Alan?
Yeah, I think like the previous folks have said, like, this is about the server trying to send frames to you and hitting a limit and not being able to. And I think that's going to be a very sort of ugly failure mode when there's not enough. Right. And if the application knows I really need 1,000 or 10,000 or whatever, if it knows that in advance and can avoid that just by saying, like, please give me this many, or fail me now before I try, that's probably better than it not trying to do it automatically and not catching up.
In particular, Alan, I think we looked at the scenario where you're trying to do something like conferencing, like frame per stream, and you've got, there's this kind of arms race where you have these grids 7x7 or 12x12 or whatever. So you have a lot of streams, and then you have, concurrent streams open. So it's pretty easy to see how you'd go over 100, for example.
Yeah, I think like the way we've been treating stream limits in HTTP so far has been like, 100 seems to be okay, but I think that's probably going to be applications that are going to be much larger for web transport.
So. Jordi?
Yeah, I agree with what Alan says. So just configuring at the very beginning, it seems like a good option. And also just a data point, I implemented the case that the media sends a stream per frame, creates a quick stream per frame. And this only applies to the in-flight streams. And even if you have a latency around 200 milliseconds, the number of in-flight streams is usually 10, 20. So it seems that also putting that limit, per connection. So it seems that putting that limit to something around 1,000, it's also a reasonable trade-off. Thank you.
Harold?
Harald Aldestrand. The important thing is that there has to be a limit. And we know we have to test the behavior when we hit that limit. And when we increase it or decrease it or whatever. Because wherever you say foo, someone is going to say supercalifragilisticexpialidocious. I mean, you will always get something bigger than you expect, and you need to have defined behavior when you hit it.
Okay. Thank you.
Okay, I think our queue is complete. Or do we get Randall back?
What it looks like.
Just one quick response to Harold. Okay, but what is the reason we have to have a limit? I mean, why is there a limit in here in the first place? If there is a strong reason for a limit, okay, fine. Let's just set it high and find a way to, let the application tell us if they need more than the default. But it's very hard for the application to figure out what it's going to need ahead of time.
There has to be a limit. You will not know where it is until it tests. When we did WebRTC data channels, we put in a spec that you should apply 64,000 channels. Well, 64,000 channels runs out of resources in a surprising amount of interesting places. So better have a limit and the ability to see it, because otherwise you run into unexpected behavior.
Can I ask, jumping in as chair?
Before before you go away, I just have a question for you. Do you trust the browser to the application to set that limit?
There needs to be, as I said before, there needs to be defined behavior when you hit that limit. And people are going to hit it no matter where it is. No matter whether they asked for more or less before.
Jumping in as chair, I'm going to ask you a clarifying question, Harold. I think what you're saying is that if we don't put a limit in the spec, implementers are going to decide their own limit, and then you won't know what it is. Is that what you're saying?
That's exactly what I'm saying.
Awesome. Thank you.
Is Lucas the next one in the queue? Or is it Randall? Lucas, okay.
Cool. I just want to clarify, like, nearly everything we're talking about here is part of Quick, right? It's Quick. You have to give an initial stream limit, and then it increments through the course of the connection based on effectively credit granting from one end to the other and in opposite directions. So I don't think we need to litigate how Quick works, because that's a solved problem. Like, we know what happens when you run out of credit. You can't do anything. Like, we have different application protocols that have to deal with that thing. I don't think that's the problem. The concern would be that the limit is effectively about the resources for the receiver. So you've got how much it takes to maintain potentially your peer sending you that many streams, which per streams they're cheap, but then you've got to think about the flow control, the potential that what you say is for each stream I'm willing to receive 1 megabyte. That's a 100 megabyte commitment. That's potentially okay on a client. I don't know. But if you say it's 65,000, and then you can open up multiple web transport streams. There's a comment just in the Zulip that, like, you could trivially DOS a client. So the absolute number probably needs some care, but that I don't think we need to, like, over rotate on solve problems.
Alan Frindell. Yeah, I think someone was asking, like, why do we have a limit? I think that's the answer. It's like, this limit is to protect the receivers from a memory perspective, because streams have a memory cost associated with them. I guess I'm curious a little bit how the API handles, and also the point, we need to define how it fails. What it's going to look like, there's two potential failure modes here when an application wants to make a stream, but it's at the stream limit. One is it can fail immediately and be like, sorry, there's no streams. And another one is an implementation might do it with, like, a promise where it's like, yeah, you can make a stream, but there's none available right now. I'll just wait until one closes and then you can have it. And does there need to be a timeout on that? So anyway, things to think about.
Okay, I think the queue is now drained.
We got to go away. We had one item left there, but I guess if we're out of time, can I just go to the last item? Item 4 quickly. We've added send order for streams, but the relative priority of streams to datagrams is currently undefined. And I think Chrome, as it stands, datagrams are the highest priority. So if you're pushing a bunch of data down your datagrams, you'll never actually end up sending a stream, no matter what send order you give to it. And I had a hallway conversation with Martin. He says there's a similar situation inside Firefox currently. So the question is, should we allow datagrams, something simple like webtransport.datagrams.send order, and we apply the same send order value relative to streams for datagrams to allow the application to decide how it wants them to be prioritized? Anyone see a problem with that approach or a reason it should not be done? I got a thumbs up from Eric for the minutes. Yeah.
Okay.
Okay, no queue. Thank you very much. We've taken up our time. We appreciate the chance to give feedback. Thank you.
Okay, so Eric, you're up now.
All right. I'm Eric Kinnear. We'll make this reasonably quick, but we've done a whole pile of fun updates since we last talked, which was cool because we got lots of good feedback in IETF 115. So we have landed all of the fun capsule design team changes, which is great because it feels like we've talked about that for several meetings now. We've also done a number of other issues that I wanted to just highlight here and talk through. Feel free to go through in the PDF of these slides and click on these links. But all of these have now landed and the text should be in pretty good shape. One of the big changes that we talked about in 115 was that we wanted to be able to send anything that was allowed by flow control before you get back a connect response. And this is actually going to come back to an issue that we're going to discuss a couple slides from now. So it's worth thinking a little bit about. But this is rather than waiting a full round trip to say, hey, I'd like to talk to you using web transport, and then have the server say, yes, that sounds great. I totally talk web transport. Let's talk. I could say, hey, I'd like to talk to you about web transport. And by the way, here's what I'd like to say. So that's a fun one. Other things, we changed some status codes. If anybody looks at that and chokes on it, like now's the time to speak. It's just a number. Pull requests are cheap. We added some initial flow control windows. We ended up spelling that as a single web transport init header field. So rather than having all the different, I can have stream level flow control, web transport session / connection level flow control, stream limits, all that kind of thing. There's now just a single header field, trying to be reasonably minimal, that just says, hey, by the way, these are the initial limits. That connects back to that one earlier we were just talking about, because you can only send the capsules that are allowed for flow control. So it helps if you're allowed to send something. And then the last one, which we kind of went back and forth on over the past couple of meetings, we had a setting for enabling web transport, and we also had a setting for max sessions, and one of them only had to be sent from the server. So we had two settings, and that seemed crappy. So we now have one. And if you say settings web transport max sessions is 0, then you don't support web transport. And if you say that it is anything non-zero, it's as if you said settings enable web transport is 1. Next slide, please. All right, so this is the particular spelling of how we ended up landing the web transport init header field. So it is a dictionary, structured field, because structured fields are great. And it gives you the initial flow control limit for both unidirectional streams coming from the remote side, as well as bidirectional streams in each direction. And so you can essentially just pack that all into the same header field. And at that point, when you say, hey, I would like to talk web transport, by the way, if you'd like to start sending me stuff right away, here's how much I would appreciate you sending me, because otherwise you're going to be very sad and not allowed to send me very much. All right, next slide, please. There are a happily short number of remaining issues, which either means that we need some more people to read the draft and file some more issues, or we're actually making some progress. Those issues are first some examples that need to be updated, which is mostly editorial. If anybody gets excited about that, holler, but we'll do that. The other two we actually should talk about. One of them is error handling, because that's one of those things we don't want to forget about. And the other one is flow control, because flow control is fun. Next slide, please. So for error handling, the proposal that we have is that any kind of violation, any other fatal error that you run into can cause us to just reset the H2 stream and destroy the whole web transport session. And that's kind of a fun and interesting thing, because the last time we talked about this, we all nodded and said, yes, yes, we want this to look just like we do it for H3. This is not quite exactly how it works for H3, because H3 has a bunch of other streams that are all part of that web transport session. And we're about to spend some time talking about how much fun it is to try to close some of those streams. In this case, we're a little bit lucky because H2 is packing everything onto a single H2 stream. So if you nuke that H2 stream, you're done. So this is not quite the emotional equivalent of what we were doing before, but I think it is far cleaner and simpler. So barring any objection, I think the proposal sounds good, which is the instant you do something wrong, we say, great, your session is gone. Wonderful. I don't see anyone running to the microphone to say, no, I want more complexity. All right, next slide, please. All right, I'm going to paraphrase a little bit from MT here, but we've got two remaining issues other than everything we just talked about, and these are so far the last ones. I am tempting fate here. About the initial limits for flow control. And so the problem that we're trying to solve here is what I was just talking about earlier. You can send any capsules that are allowed by flow control without waiting for your 2xx response back from the server. And that's really nice, because I'd like to be able to send all of the get started on whatever protocol I'm running over web transport, start talking to the server about whatever it is I want to say. But in practice, this really means that you can send flow control frames, which is nice because you can get things starting to open up so that the server can send you stuff. We now have the wonderful web transport init header so that you can actually get your initial limits right there. And you can also send datagrams, because datagrams aren't super flow controlled because you can just drop them. But if you actually wanted to send useful data on useful things like web transport streams, it's wonderful that we said you can send any capsules allowed by flow control. But what we really emotionally wanted was for you to actually be able to send useful capsules. Next slide, please. Nothing against datagrams, they're fun too. So the opportunity that we have here is if we were to define non-zero stream and data limits for flow control, we could allow both your client and your server, right? Because here the server is usually allowed to send back actual reliable data in that first round trip. And seeing as we spend a lot of our time trying to contort ourselves into updating protocols to use fewer round trips, it seems a little bit silly to cheerfully say, yes, we want extra round trips in this one. Next slide, please. So we have two kind of options here. And I think this is where we really want some feedback and some guidance. So one option is we could just say we're going to have a default limit for all implementations. And this comes back to what Will was saying a little bit ago of, hey, if I'm going to have my browser have a limit, maybe we're just going to have everybody pick some limits and we'll just hope that works. Or the other option is we can communicate some of those initial limits in settings. Next slide. Should take us. Yep.
I see a queue building. If it's relevant to this slide, go up. Otherwise,
yeah, it's this whole section. So yeah. this is the last section. So if you want to go stand in line. But
all right. So finish that slide and then we'll take questions. Okay.
Yeah.
So we'll go to the next.
Yeah. Thank you. So we're gonna just talk briefly about each of the two options and then we'll discuss. If we do have a default limit for all of the different implementations, that basically just says that now everybody who wants to implement web transport has to support at least this much space. And that's potentially hard if you're on a constrained device or you're trying to do something that's a little bit more specialized. It's a little bit awkward to say, hey, so I can't support 1 megabyte across 100 streams because that's 100 megs and maybe I don't have 100 megs to give out. Also, how do you choose the value? What are you going to do for that? If we're going to choose the value, I think MT had a suggestion that we could always base that on some of the values that we send for H2 in settings. So we could either pick like 100 streams is what you get, or we could say it's some multiple of what you allowed for your H2, like you're allowed to use half of what H2 gave out, something like that. So there are ways to do that. But if we go to the next slide, we could also communicate about these things, and talking to each other is occasionally a good plan. This allows anybody to sign up for only as much as they're really willing to give the resources to. The place where this becomes hard is that the H2 settings are shared across every web transport session that's happening within your H2 connection. And that becomes extra fun because we then say the magic word intermediary. And now you have to look at who is upstream of you or downstream of you and make sure that what you're going to advertise at the very beginning of everything matches what you think is on the other side of you, or sign up to buffer it. And I believe that brings us to our discussion moment.
Lucas Pardew, for this initial limits thing, the idea of a default sounds horrible because it's gonna spend forever trying to pick it. The settings seems more like the logical equivalent to what we can do in QuickLand already with transport parameters. If I remember correctly, you have to, the client would have to wait for the server's settings anyway. Is that correct? To be able to send the web transport request?
Yes.
That it would then send the additional stuff on. So you're not going to introduce any additional waiting or blocking there. So that seems okay. I think just create a setting and figure out solving that problem would be my inclination. Cheers.
Ian
Sweat. Yeah, I think definitely a default is not what I would prefer. A setting is fine. Inferring it based on the existing H2 setting seems a little ugly. Like I'm not really sure I like that. So I'd rather just have a dedicated one. It doesn't seem particularly hard to implement.
You may not have been thinking about web transport when you set your H2 settings.
Right.
Yeah.
Victor?
Victor Vassiliev, Google. I am generally opposed to using the settings. There are many reasons, but number one is like the settings is for multiple sessions, which might not have anything to do with each other. And number two, this generally goes against the design of web transport over H2, where almost everything is communicated like in band, and like you could run it over H1 and everything would just work fine. And that's a property that makes implementation much more easier. I am moderately positive on some reasonable initial limits for some definition of reasonable, but it sounds like folks here do not like that, so we might be just stuck without any initials.
I do think that the fact that it's shared across different sessions is an interesting challenge that we're going to have to figure out if we do decide to go that route. For purely the layering and the H1 pieces, that doesn't concern me quite as much, because if you did want to run all this over H1, essentially what you're saying is I'm willing to take an extra round trip because I don't have those values available, and so I can default to 0, right? But like...
Okay, so you're saying that whatever we do here is like an extra layer on top of what we're...
I don't know if I'd call it an extra layer, but...
Like optimization.
Essentially, we're saying that if you assume that you start at 0, if I choose to tell you a non-zero value up front so that you can send me things before we've had a chance to exchange the header, that allows you to get started sooner.
Okay.
Clarifying question, Eric, since I'm hearing some difficulties with settings, would using a header with a response be an option here?
The challenge is that I have not yet sent anything to you on this stream, and I'm sending you a connect request. And before I get a response from you, I would like to also send a bunch of things on that same stream that are web transport capsules. And so before we've had a chance to say, hello, here's how I'd like to talk web transport, I need to know how you would like to talk web transport.
So the only cost here is the round trip.
Correct.
Okay. Which is something that we, as an option, and not stating an opinion, we could accept that cost and say, for H2, you eat a round trip. Like H2 is not the fast one. If you want fast, you get H3.
We could do that.
Ian Sweat, what about using a setting but still requiring the header and basically saying if you like send back a header value that violates the setting, then like, you know,
don't
close the connection and like run away.
Yeah, I mean, we're good at resetting the stream, so yeah.
I mean, because does that mitigate some of the intermediary proxy things because it's still in band? You're basically making an optimistic assumption about what the peer is going to do, that they're not going to reset your stream.
Right, and if you are an intermediary and you are sending these things, like if you do sign up for more than the person on the other side of you is willing to deal with, you are now stuck holding that bag, and your choices are either throw it on the floor and say, oops, I screwed up, or pay to buffer that data, and either is fine.
So as chair here, I'm not seeing a whole lot of consensus in the room, but it would be nice to figure this out. This is the perfect kind of thing that doesn't matter that much, but that we can rat hole on for hours. So to kind of reframe the discussion, like, is there one thing that everyone could live with? Because like at the end of the day, these details for H2, like if we get them horribly wrong, it's bad, but I think there's probably an answer here that people can live with.
It sounds like we had significant sentiment against just signing everybody up for a default as part of doing web transport. And I think narrowing the set of options by removing that one would be helpful progress, even if nothing else. Is that a thing that everybody would be comfortable removing? I see a thumbs up, and I see a Lucas who was kind of maybe not really in the queue.
Bernard, I see you locked the queue. Are you thinking we don't want to do this now and you want to punt it to later, or?
Yeah, just want to make sure that I mean, we could come back to it, but I just want to make sure Victor gets the time that he needs. I know we probably have, you know, a good amount left. But
how about this? Yeah. Let me unlock the queue very briefly and take Eric's suggestion of, can we live with not having them be defaults, and then we'll figure out how to communicate them later. Is that something that the room can say we're okay with? All right, I see Victor nodding.
Thumbs up, thumbs up.
Thumbs up. Okay, great. All right, that is progress. Thanks, folks.
Thank you. That is very helpful. All right, and if we move forwards in our slide deck, I believe.
Okay.
Voila.
I think that's it. Because the next slide is Victor's. Victor?
Yeah, that's me.
Have the floor.
How do I just tell you to change slide?
Yeah, tell Bernard.
Okay. So we actually this time have a lot of updates since IETF115. We merged a lot of PRs. That this is the first time I don't think I even can fit everything on one slide. First one, Eric already mentioned, the capsule design team. The second one is there was a long-standing issue that were missing text for describing how to do throttling of outcoming web transport sessions. So we just added tags that if you're a browser, you should do that. Leave it up to the implementation. We there were some clarifications regarding how settings changes behave across ZRTT. Even though we don't support ZRTT, you cannot go from ZRTT where you supported web transport to ZRTT where you didn't. There's 93 and the other change, we now require you to explicitly enable Connect protocol. That means you have to opt in, like before it was implied because there was no WebSockets over H3 defined, and now we require you to explicitly opt into Extended Connect. And there is a similar one for explicitly requiring and opting into H3 datagrams. There was some update around the origin header. We previously said it's always required. We now say it's only required to send if your browser. Next slide. So there is a kind of a big one, 96. So we had the magical frame called Web Transport Stream, and whenever you send that frame, your stream that used to be a regular H3 stream magically transformed into a Web Transport Stream. We changed this a little bit. Now it's not a frame, it's just a special value that you have to send at the very beginning of the stream. And you can no longer send it in the positions other than the beginning of the stream. There is more pending clarification text from Lucas that I still need to finish reviewing. But there is and the last big one is that there is clarification on how to do the situation where you have one web transport session on a connection, and you close that connection, but you want to close the web transport session and make sure that the custom application error code that you put on the stream has arrived, and there are some recommendations that if you're doing that, you should wait until it's acknowledged before you tear down the entire connection. So those are the major updates. Now let's go to issues. And the next slide, there is issue 77 that is related to the fact that if you open a stream that's web transport data stream and reset it's too fast, then the peer will never know it's a web transport data stream. And this has some unfortunate implications that we don't want to deal with it. Today we are not going to discuss this because this is currently blocked on Quick Working Group reviewing an extension that would solve this issue. So I put the time for the Quick Working Group meeting, and you're welcome to attend if you care about that.
And Victor, to add to that, for anyone who wasn't in the room last IETF, we discussed this in web transport, and the consensus from our meeting was to have this happen in quick, and we reached out to the quick chairs who agreed. So that's what's happening now, and if you care, please come.
Yeah. Alan?
Alan Frindell. My question is, maybe it's premature. Let's just say this extension is adopted in quick. Do we think web transport will require this extension, or can you run web transport without it?
I would expect us to basically require it because there are like, if you do not require it, 99% nothing will happen, but sometimes the things that are supposed to be reliable and consistent will just suddenly like disappear. So this is like, I would not attempt to open the Pandora box at what would happen if you do not require this.
Actually, Alan, before you sit down, we hadn't realized that that was a comment, something that could be contentious. Are you okay with requiring it? Because like that was a kind of a mindset. But let's pull the room. What do you think?
Are you asking me or asking the room?
I'm asking you first, since you were the one who brought it up. But then anyone else who cares to join the queue.
I've seen comments on the mock mailing list indicating that quick stacks are not as malleable as we maybe think they are. For example, expanding how they do prioritization. Some people think that's going to be really hard. And if that's true, then I also potentially see implementing, whoever has that opinion probably also has the opinion that implementing this change is hard since, well, I don't know, I'm not going to make a comparison of which is easier or not. So I just think if we're going to require this extension for web transport, then that is raising the barrier to having web transport a little bit, I think.
That's a reasonable point. Thank you. I guess then what I'm realizing is the implementation difficulty will depend on how complex the extension that happens in Quick is. So maybe we need to put a pin in that until that happens. So, but if you're in the queue, share your opinions, but maybe we'll have to wait until we have a bit more clarity on what's going to happen in Quick.
Just want to point out that we discussed this last time in at the IETF 115. And we said it should be a requirement. As an analogy, datagrams are also not strictly required to do web transport. You could do web transport with just streams, but we still say that the datagram extension is a requirement if you want to do a web transport. And we said this should be the same for this extension, whatever it may be.
Okay, let's figure that out once we get it. Yeah.
Kazuhoku. So I just wanted to ask the question of if it's going to be an optional thing, then why do we have to make changes to Quick? So that was my point.
Lucas Pardy, speaking as an individual, I think requiring this makes sense, and I wouldn't use it as like the potential difficulties as a reason not to do it. I would use the desire to have this thing to improve web transport as a baseline for people to build on, as input into trying to make the design of the other thing sufficiently implementable by quick implementations, and have people who are implementers state how hard or not it is about doing things in Quick, not hypotheses. So cheers.
Yeah. Just one thing. Yeah, just one thing I wanted to say, which is that there are a number of issues with the handling of resets that will affect things like mock relays. The draft that's been proposed handles some of them, but not all of them. There's more variability in quick implementations, I think, that will potentially bite implementers of mock relays. I'm not sure whether that says that it should be discussed in mock, but there are dragons out there that aren't solved by the draft.
I wanted to comment that we already require one Quick extension and like at least 3 HTTP3 extensions. So I don't think we should be particularly concerned about just adding another one. Next slide. Bernard? The first one where we actually get to talk, and this is partially unresolved. So we currently define an 8-bit error code space for recess streams, And the way we define it is we take like a small chunk of H3 error code space, and then we like remove the grease code points, and it's like continuous except for those. And people have complained that 8 bits is not enough, and I kind of sympathize with that statement. So there are multiple options we can deal with this. One of them is we can just leave it as this. Another is we can use the grease algorithm thing to just take like their H3 error code space is like 64 bits, 62 bits long. So we can take 2 to the 32 of it, and that would be a relatively small fraction of it still. The other option that was pointed out to me, and I believe it works, but I'm not sure, is we can just use the fact that we know in advance that it's a web transport stream, and this requires like us to do reliable resets. But if we know that, we can just ignore the fact that there is a potential namespace collision. And if it's like web transport data stream, we'll always take the reset error code and assume it's a web transport error code as opposed to H3 error code. That should work. And also depending on the outcome of tomorrow's discussion on how reliable reset works, there might be another way to attach metadata. What do people think? Ted?
Ted Hardy. Sorry, it's a long way around. I just wanted to say I think using the entire space and not worrying about the collisions is probably suboptimal, and so I would be quite fine with the reset code in the metadata blob or the expand the space, but I think using the entire space and ignoring any potential overlap is I see dragons in the future there, and I would like to avoid them.
So the way we like try to avoid dragons is this is safe as long as we guarantee whether we know if something is a web transport stream or H3 stream. And if we solve the previous issues, I believe we do always know that.
Yeah, and so my only concern there is that if there's something that you want to signal at the other layer at some point in the future, this is a web transport stream, but your error is actually an H3 error related to it. You're going to have to double you're going to have to create an error at the web transport layer that says you have an H3 error, and it's this one, right? If there's something at the H3 layer that you need to communicate in web transport, you're going to have to recreate that capability in the web transport ones, and that just seems like let's avoid that whole thing. You've got other options. Let's pick one.
Okay, that's understandable. Thank you. Any other people who have opinions?
I do. I opened this issue. So I don't particularly care if I have 62 bits or 32 bits. Just having 8 bits is not enough, especially if you're doing like more complicated stuff on top of web transport. You really run out of error codes very quickly.
Is there any downside of just expanding the space to 32 bits and calling this a day? I mean, that still gives us like what, billions of...
There is.
I'm just asking.
I would have to write more test code.
Okay. It seems like the most straightforward option, but that's my first perception.
To answer that from a policy question, I was looking through the INF policy for these error codes, and what I'm reading is like asking for an unreasonable amount of space is discouraged. But if we ask for 32 bits in the 8-byte space, which is like a 2 to the 62 minus 2 to the 32, that's just negligible. Maybe the INF people will get annoyed at us because that's going to do something ugly on the page, but I think that's fine. So I think we're okay from a policy standpoint.
Yeah, special Z registration is going to be really funny because it's like from A to B except for every 21st error code.
Lucas?
Hey, yeah, I put it in the chat. I agree with Ted. Like, I'm very nervous about just squatting over the top of HB3 because of potential aliasing and conflicts like that. So taking us a bigger chunk than 8-bit seems okay. I'm sure we can work with Ayana to try and make this better. Strangely, from the capsules registry that we're the experts on, David, I had somebody I was speaking to who unintentionally, purposefully used values from the reserved range to do actual things, and they shouldn't have. So I was already speaking with Ayana this week about how we might be able to improve the descriptions of these like greased ranges to make it even more obvious what they're supposed to do. So this might just fit into that too as a piece of work I was thinking of doing anyway. So yeah, I'm not against taking a bit more space from that registry, subject to the designated experts doing the review, and I'm willing to help with that.
And one of our experts, or actually, so I see Alan, and Mike Bishop is the other. I don't know if he's in the room. But Alan, if you think this is a bad idea, please stand up. Give us a thumbs up or a thumbs down. Or words. Yeah, please.
Which idea is a bad idea? There's several ideas. Some are bad.
As an INA expert, do you have any issue with us registering 32 bits plus however the degreasing is out of the 8-byte space?
I mean, I agree with Victor. It's going to look ugly. I think I agree with you that it's a drop in the bucket. I'm also a relatively new IANA expert. So, and I believe my expertise comes more from the HTTP side than the registration side.
Oh, don't worry. None of us IANA experts know what we're doing. So unless you think this is a terrible idea, we're fine.
Kazuhoku, I just want to say that what Ted raised is a perfectly valid concern, though I'd also point out that in web transport, we've already decided to put multiple sessions into a one single HTTP 3 connection, which is already, has the resource allocation problems and those things. So I would.
Two things. Can you state your name, and also can you get in the queue? You've been jumping the queue. Can you state your name and also use the queuing mechanism? Thank you.
Oh, sorry. My name is Kazuhoku. And well, I just want to say that we are already on the jump wagon of squeezing things onto the HTTP mapping. So I prefer just doing the 32 bits thing and calling it a day.
It doesn't sound like we have any conclusive answer, so I think I will wait until at least like tomorrow's session on reset metadata and reliable resets, and we'll see.
Actually, Victor, I'm hearing some folks saying that that's fine, and some folks saying that using the entire space is not good. I didn't hear anyone objecting to the 32-bit unless I misheard.
Okay, that's true. That's that sounds like the default course.
Yeah, so before we move on, does anyone strongly object with reason to that option? Lock the queue so you can, but all right, let's go with that then, Victor.
Okay.
We'll confirm the consensus on the list as usual.
Next slide. Oh, that's a fun one. Flow control. So currently we always have stream level flow control because that's provided for by quick URL streams. There is no way in web transport over HTTP3 if you're running multiple web transport sessions on the same connection. There is no way to limit total data that is sent by an individual session. And there is no way to limit the total number of streams that is used by an individual session as a peer. And that is awkward because technically, as I said, if you run web transport of H2, you get all of those limitations. If you run web transport over a dedicated H3 connection, you also basically get all of those. So the question is, do we want to actually add capabilities for this? And if we do, should they be optional for only when you do polling instead of running one transfer session and say your quick connection? Do people have opinions on this matter?
Lucas?
Lucas Pardew. I can imagine why this might be needed. Like, I can imagine use cases, but I don't know of any that exist personally. Like, but it feels like the kind of thing if you wanted to try and do, you probably want to try and do it in Quick, not in Web Transport, if that makes sense, as another extension. And that seems like an even harder problem than the reliable resets. But like, could we live without this for now and maybe try and solve it later?
Sure.
So Lucas, you're proposing just keeping it as is for now, and in a future document, if it's a problem, we can change it?
That's my proposal based on not hearing any concrete use cases that are kind of, if people presented really good reasons, yep, that's fine as well.
That makes sense. Thank you.
Alan Frindell, I feel like we've talked about this and that most people don't feel like the complexity required to support 2 and 3 and H3 are worth it right now. Are we reopening that, or did I misunderstand what we're talking about?
I think we had an issue that sounded like it was very weirdly inconclusive because the consensus, like the conclusion on that issue was that we need 3 but not 2. But I was very confused at how that got recorded because I do not remember us coming to that conclusion.
I think our conclusion was we thought 3. Okay, my personal opinion is that we ought to have all of these. It's part of the Quick API. My view of Web Transport is that it's taking an HTTP connection and giving you the Quick API on it. So when we're not exposing all of it, then we're kind of breaking things a little bit. I also think that were fewer cases for pooled sessions when we were only thinking about kind of browser use cases. But the way I see people looking at using Web Transport as a building block in mock, where a browser may not be involved in either side of the connection, may want to take advantage of these things. That said, it doesn't necessarily change that implementing 2 and 3 is hard. And I don't think there's a lot of appetite.
And Alan, just as a technical point, if let's say mock needed this, but this needed to be added as a separate document as an extension here that then mock would require, would that address your concerns?
Do you mean like if Quick somehow provided this like subdividing of the flow control space as a Quick extension?
As a Quick extension, or if mock builds over Web Transport as a Web Transport extension?
Yeah. I mean, those things are probably fine. I don't know that I see us actually solving this problem right now.
Okay. Thanks.
So yeah.
Eric Kinnear, just really quickly, I think the reason that we had said that we wanted 3 and not 2 was because 3 was not super hard and 2 was harder. That being that it's not massively hard to limit counts of streams, modulo telling if they're gone or not, and that you got stream level for free. And so that was why we said let's bite off the piece that seems useful and helpful to be able to partition things between Web Transport sessions, but within that session you're kind of on your own.
Do people here believe that implementing 3 but not 2 would be generally simple and useful?
So Victor, remind me, so in the draft we have 1 right now, but not 2 and 3, is that right?
Well, yeah, 1 comes from Quick. It's always there, yeah. We don't have anything for 2 or 3.
Okay, and I'm hearing folks saying like it would be nice to have it, but it sounds hard. And I'm not hearing anyone jumping up and down saying like, oh, let's do this and here's a great solution. So can anyone not live with us just sticking with 1 and moving on?
Okay, works. Does this work?
Okay. Yeah, we can hear you.
Took me too long to get to the queue.
So. Yeah, that's fine. Go ahead.
Just because no one's tried, I think, for 2 and 3. That's the thing that concerns me. That maybe, Victor, you tried? in your,
not actually tried to implement two or three.
I don't need an implementation. I just need someone to give me an idea of what it would look like. I can imagine several things that would potentially give us an approximation of a subdivision of the protocol that wouldn't be very complicated, but would potentially allow you to, for instance, reserve a few streams for another session or something like that. So I would at least like to see an attempt made before we go, oh, it's too hard. Yeah.
All right, I'm getting thumbs up for that. That makes sense, Martin.
Because I think we can actually do two in the same way as we can do three if we're willing to make some sort of compromises on the design.
We would need to have a definition of what's data we're counting.
Right, right. And that would, I think, be possible. We may have a system that is somewhat inflexible. We may not have a system that is not as dynamically adaptable as the current flow control limits that are endlessly flexible in different ways, but we may be able to do, for instance, we might have a system that says you have this many streams. Every time you use one of these, you use up a stream identifier, I'll have to give you another one later, very much like how Quick manages streams. And the same could be said for data, and just have extra flow control pools that you pull from. Now, they have some very interesting properties from an interaction perspective, when you now have connection level flow control, stream level flow control, this new level of flow control. So I think it would require a little bit of thought to avoid some of the more obvious sort of deadlock conditions, for instance.
And we'll also have to deal with like the issue with interaction between resets and flow control limits.
Exactly. You would have to have some some access to what is going on in the quick connection in order to effectively do it. You'd have to have very clear definitions of what it means to have a stream, and yes, the reliable reset question rears its ugly head again. All of those sorts of things, but I think we could give it a try. Yeah.
Lucas?
Lucas Pardew. I'm not against people giving it a go, and I'd like read like a sketch of the design or something, but just hearing, oh, we want multiple layers of flow control sounds like the H2 HAL we have today that everyone hates and that we enjoy because we have Quick with one. Hence why I think it's something that really belongs in Quick, so it's consistent and it's implemented by the people who do that bit. I don't want all the web transport people to have to implement boring flow control stuff just because there might be one app in the world that might need to use this thing and doesn't even know how to use it because it's so complicated and impossible to debug like all of the H2 flow control problems we have. So I'm willing to be proven wrong, totally. I'm have that discussion, so.
Ian Sweat. I tend to think probably this should be in Quick, but I'm not 100% sure without like actually thinking through an entire design. But personally, I would actually rather, instead of saying like, we want to try to have a design before we move forward on this, I kind of would rather just like move forward on this. And then if someone comes up with a design that like people like, then we should like consider it and change it. Like there's something to be said for like saying we're going to close this, or we're going to say this is done for now unless someone actually comes up with a better proposal.
Let's see, for the folks who thumbs up MT's idea, how do they feel about that? Because I do like the idea of putting the burden on proof of people who would like to see it to actually do the work. So who's volunteering to do this work?
We can talk about it. Yeah.
Eric Kinnear, I just wanted to say, we're not like doing lots of fun H2 flow control because we thought that was just a good time. We're doing that because like otherwise stuff breaks and you run out of memory and people are sad. So it'd be nice if web transport didn't just like break and run out of memory all the time too. And it'd be nice if it didn't break and run out of memory all the time because of something that somebody else was doing that you didn't even cause. So, but anyway, yeah, I think I very much support what Martin was saying of like, let's at least try. And if we say this is too hard after we've actually looked at it, that's nice. But like, oh, we're on the wrong time zone and it's hard to like think about it is probably not the right answer.
Okay, that's fair. Since you're both editors of various documents, let's discuss this at an editor's meeting and figure this out. And maybe we invite Lucas for this one, and anyone else who wants to.
Or maybe we don't. I think Ian's suggestion is a great one, by the way. Burden of proof for they who want the feature. I think this is something that could be added as an extension. So if Victor wants to be able to proceed with the documents and publish them, that's a great goal to have. And if we can do that by agreeing that this problem is not in the documents right now, unless someone can write a draft, convince the working group that it should be integrated into the documents before they get it too much further, that would be how I would suggest we do this. And because I think it can be done as an extension, there's some details to work out there. Anything can be done as an extension. If you're willing to work hard enough, I think we can probably just not block on the resolution of this issue. What I wanted to sort of object to was the notion that we were going to bury this forever, because I think there is some value in here, as Alan pointed out, that like it's useful, particularly if you want to do the connection pooling stuff. But I think given that the predominant web transport deployments right now don't do any sort of pooling, this is not a problem so much for them. So we sort of have a little bit of breathing room on this one. I do want to sort of comment about that at some point as well. I think that an untested, unused feature is a great thing to have in a protocol if you like things breaking badly in the future. So we should make sure that gets tested more.
Yep. So here's a proposal then. We keep the issue open until the next IETF, and that gives us, 3-4 months to, if anyone is interested in proposing a solution for solving this, we'll give them agenda time at the next IETF. We'll require it to be written down. And if no one has done the work, then we close this. So that won't delay us. But if someone wants to do the work, we will absolutely give you time to present it, and we can discuss whether we think it's, oh, wow, that was easy, let's put it in, or, oh, this is way too complicated, let's not. Does anyone object to that plan? All right, I see a shrug. I'll take it. Okay. Should we move on to the next slide?
Sure, let's go to the next slide, which is the last slide I'm presenting. And the most fun one, which was last, is support for HTTP redirects. We have to roughly decide between 3 options: requires them to be always followed, requires them to be not followed, and possibly we could allow browsers to be followed, but API-wise do not follow them automatically, but instead inform the users that they're being redirected. So why is this complicated? Normally redirects are not particularly hard. Here in web transport, we allow you to send some stream data before we ever receive the HTTP 200 from the server. This, of course, puts us in a tricky position that if we get HTTP 200 and we get redirected, well, what happens to the stream now? Do we require application to deal with this? Do we attempt to automatically reserialize all of those I/O operations that the client did? If we attempt to reserialize them, what do we do if flow control window changes between the 2 sessions, between the websites that got redirected from to the websites that got redirected to? So those are the things that make it complicated. What opinions do people have?
Cedric, not an opinion, a clarifying question, because I don't think I understood you correctly. What I thought I heard you say was you had a 200 OK and some data received before the 200 OK, and then you got a redirect. Is that?
No, the 200 OK is not redirect.
No, I know. I'm quite familiar with it.
The situation I'm concerned is you send data, and then you receive 300 something.
Okay, so somebody sends me some stream data, and a 302 telling me to go away.
No, let me jump in to clear the confusion. The client is allowed to send data with the request before it receives the response.
Okay. So thank you for washing away the sin of my misunderstanding.
Who's Adam?
Yes, so I just want to disagree with one thing you said, that redirects are simple. Redirects are not simple. Redirects are incredibly complicated and dangerous things. So...
Sorry, I was just going to say, what makes say more? What makes them complicated? We want to hear it.
I forgot to say my name. Adam Rice, Google. So, firstly, do you want to focus on what makes them complicated? Well, okay. So there are in the fetch spec, there are 20 steps to the redirect algorithm. It has interactions with cause. It has interactions with authentication. It has interactions with timing, although that's not an issue for web transport. It's frequently been a source of privacy and security problems in the past. Now, outside a browser environment, I think redirects are much less problematic, although a library may find itself somewhere where it didn't expect to be, and maybe that's not so great either. So I wanted to mention the security issue with redirects in browsers, that if a web page takes a web transport endpoint as an argument and verifies that it's on the correct origin, it can then be redirected by an open redirect on the same origin to a hostile site. So this is essentially a cross-site attack where the attacker passes in a URL with a web transport endpoint which appears to be safe, but actually isn't because of an open redirect on the same site. Now, open redirects are surprisingly common, even in this day and age. Google has one. So the open redirect thing is not theoretical. Whether you would actually write a page that takes the web transport endpoint as an argument in the URL is debatable. But that's the security issue. And that's the reason why WebSockets do not support redirects. Reason 2 would be that the fetch standard has 20 steps in its redirect algorithm, but we can't use those 20 steps directly because at the final step is calls into main fetch. We don't use main fetch because it's for fetching and we're not doing fetching. We only use the obtainer connection part of the fetch standard. And that's more about the W3C than the IETF end. But in the browser, we have to implement the equivalent of those 20 steps for web transport, and we can't reuse the implementation, and the standard will also need the equivalent of those 20 steps. How much of those steps go in the IETF and how many of those steps go in W3C is not clear. The third item is I'm concerned about creeping featureism. WebSocket suffered a lot from this, where it adopted some HTTP features and then people expected it to have all HTTP features. So how we've implemented this in Chromium is we use the HTTP stack to make a WebSocket connection. But this is extremely ugly because we need, at the end of the handshake, we then need to steal the socket out from the HTTP stack to use for WebSockets. So for web transport, so far, we've not had to use the HTTP stack because we're not a full HTTP client. But I'm concerned if we start supporting more and more HTTP features, we will ultimately be in a position where we're re-implementing so much of HTTP that it doesn't make sense to use a separate implementation anymore. So my preference is for disallow. However, if one option is to do what happened in WebSocket land, where the IETF said redirects were okay, and the what WG said you shouldn't redirect.
What would you think about letting API surface 300 messages but not do anything about them?
That's fine, as long as the browser can just drop them.
Okay.
I think I am concerned about the risk of non-web clients getting tricked by redirects into doing things they weren't intending to do. But since I'm working on a browser, that's for someone else to worry about, I think.
Okay. Thank you. Alex.
Alex Chernowski, I'm actually currently surprised that I don't think we ran into this problem from Ask. I don't remember us talking about redirects because we have sort of similar issue where you can opportunistically send data. David, do you happen to remember us having this conversation and what we decided here? Because it feels like there should have been prior art.
So part of this we didn't discuss because a lot of these complexities are in a web context, and like you don't do connect HTTP in a web context from a browser, so those don't. But in terms of let's say you send a datagram opportunistically for a quick and then you get redirected. Yeah, I guess you got to send it again. We forgot to mention that in the document, but I'm pretty sure someone will. Actually, you know what? I rescind what I said because I forgot to account for that in my implementation. So
no, we definitely did talk about the fact that the opportunistic data might be lost in the context of extensions. So I think that's actually covered in MASC. So I guess that means my opinion is somewhere between disallow and clients can handle it. But I think allow is probably not a great idea.
All right.
So I support.
Speak closer into the microphone, please.
Sorry, Kenji Ishibashi. So I support what Adam said. So the supporting redirect brings much complexity from the perspective of web API. So I'm wondering what's the benefit to allowing redirect. So probably this was discussed in the previous meetings. So yeah, I'm wondering what's the benefit of supporting redirect.
So from memory, from the previous meeting, we got consensus on saying either everyone must support them or must not do them. Like that whatever we did, it would be a forced thing to avoid interop issues. But we didn't get consensus on whether we would fully do it or fully not. From memory, I think Martin Thompson, who's behind you, was the one arguing for it. So I'll let him answer that question. Bernard, are you okay with Martin jumping in the queue for that?
Yeah.
All right, we'll do the others first then.
So yeah, if you don't have the huge benefits, so I like to say that we want to disallow redirect. Yeah.
Okay, thanks. That makes sense. Bernard?
Yeah, so that I had a similar question in that, we have go away, we have drain. So I'm wondering what absolutely you get from this redirects that you couldn't get, 75% of the same thing out of what we already got. And to go back to Adam's point, we've had a bunch of people who are under the mistaken impression that they need to have a full HTTP stack to implement web transport, and that is definitely not true. But it has actually thinned the ranks of implementers because that misimpression is out there. So I don't want to feed it anymore by adding more HTTP stuff we don't really need.
That makes sense. Yeah, remember to walk up to the microphone. Oh, right. Thank you for taking notes.
Eric Kinnear, Apple. So I just wanted to support something that Adam said, which is that we also support WebSockets, and we also use a full HTTP stack for WebSockets because people also came to us and said, hey, it's HTTP. Why doesn't it do all the HTTP things? I want to do this ugly, gross thing over here, and then I want WebSockets. And you say, okay, you can have two ugly and gross things. So it's a little bit less painful for us to try to rip out the not socket that we have underneath. But it's still a very similar thing of now you've got this HTTP thing happening at a layer that didn't really originally think that it was full HTTP. So it would be nice to have a very clear reason why we think we want to be a full HTTP stack. On the other hand, is there really a chance that people aren't going to ask us for that in a couple of years anyway? So.
So Martin Thompson, I think that I've been convinced by the arguments that I've heard here. I really wanted this to be clear one way or the other. And I didn't want the answer to be sort of, well, we thought about it for 30 seconds and said no. It seems like we thought about it for more than 30 seconds. And this, even just the fact that the client can send something and then we have to think about how this integrates with flow control on the new connection and whatnot is enough of a headache for me that I think that the approach that Mask has taken here, which I have right in front of me, which is if it's not 2xx, it's busted, is probably acceptable in this case. I would like to see us, as long as we fit with the rules for cause and all those sorts of other things, expose the information from the response from the server in those error cases back up to the client so they can make sensible decisions based on that. That means potentially handling redirects, but it means that we would not be in a situation where we have to deal with all of the complexity of saving all of that data that's come from the client in the stack and then replaying it across potentially multiple connections with all the, I mean, I'm sure we can work out all the security things. I'm sure we can, you know, work through fetch spec stuff, but maybe we just don't have to. And that's much easier for everyone. And I'm okay with that outcome.
Thanks, Eric.
Very briefly, Eric Kinnear again. I think there is a chance that we can go and work through all of those things, but actually another example to extra support what Adam was saying, we recently had an interesting privacy issue around cookies and WebSocket requests because, of course, it's actual HTTP and it has all of those problems. And so I think that is there are several very clear examples of actual real world harm that is happening from what are bugs in implementations. But even if we sort through a bunch of these issues and even if we solve a lot of these, it keeps coming up year after year as, oh, we've closed some hole in this area. Oopsie daisy, did you forget to do it for WebTransport 2 because it's subtly different in ways that are really hard to get right. So I think it's not just a, hey, this would be nice. I think we need to have a very clear need for this because it is actively harming people with WebSockets right now.
Awesome, thank you. I'm hearing violent agreement on we shouldn't allow this because there be dragons.
My hearing is we should not follow them automatically, and then like 2 and 3 is puntable to W3C as to whether we want to expose it via API. So I propose we just do that.
Yep, sorry, I meant the loud agreement was not the first option. Yep, that. All right, so does anyone object to us saying we're definitely not doing the first option and the W3C can decide between second and third? Because what that means is if we get a 3xx error, it would be like a 4xx error from the IETF WebTrans perspective. It just gets sent up to the JavaScript. All right, success. I think
that's last of my slide, and the next slide is Alan.
All right, thank you, Victor. Thanks, everyone. It's great to see progress and resolution on such things. Take it away, Alan.
Okay, so I opened this issue. I can look down here. About how priorities work when you've pooled multiple web transport sessions together. And it came up a little bit in Mask this morning. So imagine you have an HTTP3 connection. You have n different web transport sessions on that connection. And each of those sessions has m different streams. And the application has diligently tried to prioritize the data on those streams. But then how does the quick library manage to merge the prioritization between the different web transport sessions? So next slide has a picture. Maybe it'll be clear. Okay, so you've got 2 web transport sessions. In one, it has 2 streams, which I'm just using the shorthand for HTTP priorities here. There's no requirement that streams work like that, but I think people are familiar with the language. So you've got 2 streams, one at priority 1 and one at priority 4, not incremental. You have another session that has 2 streams that have the same priority and it's incremental. So there's different ways that the sending side could send that data out. So one is you just merge all those streams together and serve them. So that means the priority 1 goes out all by itself first, then the priority 3 incrementals go round robin until they're done, and then the priority 4 goes out. But maybe that wasn't really what you wanted. Maybe you wanted like, well, I have these 2 sessions and they should be round robin. And so now I'm alternating sending packets from one session and the other session. And within those sessions, they're applying the priority. So when Web Transport session 1 gets its turn, it's sending all of stream 1 and then all of stream 2. And when the other session gets its turn, it's alternating between its stream 1 and stream 2. Hope you're following this. Okay, makes sense. Made sense when I drew the picture. Okay, next slide. Then there's also a question about what if the Web Transport Connect request had a priority header in it? Then maybe you could do something like say, well, Web Transport session 1 is actually strictly more important than Web Transport session 2, in which case I would want all of its streams first and then the streams from the other one after that. And I'll note that most quick libraries I don't think have an implementation that's rich enough right now to do any of these other than, look, it's a stream and it has its priority and I will send all the streams according to priority. So to sort of merge them all together and it's all global. But I'm not sure that's the right solution. And if you look at what HTTP, Web Transport over HTTP2 does, you would sort of get this option, I think. Okay, next slide. Okay, so what do we want to say in the draft? I threw a few different options here. Option 1, don't say anything. You get what you get. Like, things will just happen. Don't worry about it. That's where we are now. Option 2, we say streams get prioritized globally, which means be careful what you're pooling together and how you set your priorities, because if one session thinks priority 2 is the highest thing and another session thinks priority 1 is the highest thing, then you're never going to get the data that you expect. 3, and if you look at what's in the data, in the priorities RFC, it sort of says, oh, when you connect, you should round robin your connects. But so maybe that is what this is. Like, okay, all the Web Transport sessions, you round robin amongst them, but then stream prioritization is relatively scoped within each session. Although that sort of asks, like, how do you prioritize those sessions versus HTTP request streams, which may also be going on the same connection. Or option 4 is that we use the priority header for everything, Web Transport, Connect stream, or otherwise, and then the HTTP or the Web Transport streams are scoped within only their session. So some other priority enthusiasts have joined the queue. Bernard.
Parrot, what probably will come up in W3C, which is there's a privacy concern here about being able to learn about what's going on in another session that I think we should try to think through. It seems, I mean, I think either way, for what you described, you could understand some things about what's going on in the other session. But I think the round robin may be a little bit less of a leak. Just something to think through.
Can I just clarify? You're saying what you can learn is that, I don't know, that if you asked for some data and then you didn't get it, then there must be some other session that is using higher priority stream data? I'm not sure.
Yeah, that's the thing, is that it looks like I could know that somebody else was using higher priority than me, as opposed to the round robin where I kind of get, it's just the relative priority of what they do versus me, as opposed to the absolute number. So I think I get a little bit more of a leak in the case where you're prioritizing across sessions.
Does the W3C have an opinion about that with respect to HTTP requests?
I don't want to pretend to speak for the W3C, but I know that the privacy people are torturous on a regular basis. So.
I see, because I mean, essentially it's sort of the same problem. I have 2 browser tabs open. One sent a bunch of requests. Another one sent a bunch of requests, and things are getting prioritized, but they used the same underlying HTTP3 connection. Then one can, I think it's the same problem. Okay. Oh, my queue's getting longer and the meeting's getting shorter. Luke. Okay. Oh, Victor, I'm sorry, I was in front of you. Bernard hopped out too fast.
Okay, Luke here. I cut the line. Sorry, Victor. So from an application point of view, if I'm writing a web app and I'm in JavaScript and I establish web transport, I'm unaware if pooling actually happened under the hood. And I think it is almost like a foot gun if it could misprioritize depending on if it was a separate quick connection or not. As in, I think option 3, by round robining, you kind of want to emulate what would happen if it was a separate quick connection. Otherwise, the application is going to have to behave separately if it's pooled or not.
Can you clarify how the application would behave differently if it was pooled versus not pooled?
Yeah, so if I assume that there's 2 separate quick connections, I'm going to get round robined over the network, right? Regardless of whatever priorities I set. But if I'm going to get pooled transparently, and now my priorities will change depending on what other applications decided to pool with me. So I either need to be aware that pooling is enabled and what I'm pooling with so I can change my behavior, or web transport needs to just pretend like we don't know about each other at all.
Okay, thanks. Oh, and the queue is closed. Okay, now it's Victor's turn.
Victor, huge priority enthusiast, was just writing priorities code right now.
Yes.
Yeah, I think so. From IETF perspective, we generally in Quick don't talk about priorities since it's an API concern. The only way we talk about them is in relation to HTTP priorities communicated on the wire. My opinion is the only thing we should say here is that the HTTP priority of the connect stream applies to all of the streams within the session.
Okay, I think that sounds to me like option 4, and I think I agree with you. I'm not just like thinking about how the local client is deciding how to prioritize data it is sending, but how is a server that has received pooled connections with various priority headers and various streams hanging off of each of those streams, what is it expected to do?
Yeah, we do not allow priorities for individual data streams. In fact, like we recently banned the only way you could do that for bidirectional streams. This is like entirely an API concern currently, but we should clarify that like the priority of the connect stream applies to entire session.
Okay, I think that means 4.
Yeah,
on this slide.
I also believe in 3 to clarify. I also believe in 3, but that's like not the layer at which we should define.
Okay. Okay, we already covered Luke, so Ian.
Ian's bet. I tend to favor option 4 as it feels like the correct option, quote unquote. That being said, I'm not necessarily convinced people will end up implementing it. I think you're going to end up with like a should or something and hope that implementations do it. But it feels like the most corruption option. But the reality is if someone did 3, I suspect the performance would be fine. I'm not sure I understand the concern about pooling and how you would actually have to change your application if you were pooled with someone else. I mean, on multiple layers of the network, like people can cause congestion and like overuse resources and then like starve you. So this seems like just another case of like the internet's a terrible place and like you have to adapt to a wide variety of conditions. But
okay, thanks, Martin.
Yeah, I think Luke made a pretty sensible argument there for ensuring that the prioritization of the streams within the session are scoped somehow. I tend to sort of think that maybe 4 is the right answer there. Probably with a recommendation that web transport sessions get the incremental flag implicitly attached to them, even when they aren't explicitly marked as such. Otherwise, we end up in a situation where we may have strict the rules as defined in the 92.18 would basically say that you just do one session and then you do the next session, and that's not going to work out great for those people in the second session. So that would be a naive way to implement it, but that's kind of what's implied by my reading of that.
Follow up on that part, because
Lucas can correct me on that one.
Why are these sessions different from HTTP requests?
Well, in so many ways, and obviously
with respect to this question.
Yeah, I think you're probably right in the sense that we probably don't need to say very much, but because as always, the signal is just input to a prioritize implementation algorithm that occurs on whichever end is applying it. So from that perspective, it's not a huge deal, but I think some advice along those lines would be sensible, so that we don't end up in a situation where people apply the same sort of strict ordering semantic that you would do for ordinary resources to these sessions, and then sort of end up in this weird state. But otherwise, I think 4 is just a refinement of 3 to allow for expressions of relative priority between sessions. And from that perspective, there's 2 things. One, the privacy thing doesn't matter because you're putting them all in the same connection, and the server at the other end sees all of them at the same place anyway. So there's no inherent privacy advantage there. The other one is it also sees all of these things as well and has the ability to make decisions about the relative priority of things, even if things are kind of a little bit crazy. So if we have 1s and 8s in the same connection, well, you know, that's their fault, and that maybe they intended for that to happen. And if they prioritize accordingly, then that might be a good thing. So I think 4 is probably ultimately the right answer too.
Okay, and maybe Lucas is also going to say this, but the priorities RFC does not have a normative statement. It just says if you're using connect, it uses a can. So you can set the incremental flag. So
right, and I think that's
you can also not set the incremental flag.
You can do whatever you want, and we may well ignore it because I think that's appropriate here.
Yeah, Lucas.
Lucas Pardue. When I joined the queue, I had a clearer idea, but the discussions completely clouded it all. But I agree with Luke's
That's
point.
why we're here.
No, I agree with Luke's point about like it sucks if you don't know what pooling's going on because like things might not work properly. I think I probably just need to grab a beer with Alan and like discuss this and try and come up with something coherent in my own head. And so yeah, I'll help you out or you help me out.
Okay, cool. Thanks. That's all I have.
All right. Bernard, any thoughts or should we close out?
I think we're pretty close to closing it out, but I'm wondering if there are any things in particular discussions we need to have or things to prioritize for design teams or something for the next meeting.
One thing we had earlier in the group was the discussion about settings versus headers for negotiating the flow control limits in H2, and we decided to not spend too much time. We could spend another 7 minutes on it, or do people feel done? No, I'm getting a thumbs up. All right. Can you go, Bernard, since you're controlling the slides, can you go back to, and Eric, do you want to come back up here? Eric? Yep, thanks. And this was slide 20, well, somewhere between 20 and 24.
Okay, I'm going to go through. Tell me to stop.
So for folks who walked into the room between then and now, the consensus is the room was not to have fixed defaults and to instead have something negotiated, but we didn't decide on whether it would be a setting or a header. Do folks have opinions on this? If we can resolve it today, that would make life easier.
Let's just say, Martin, if you also want to articulate this, having filed the issue, you may do a better job than I did in these slides. But so the question here, I think we said that we were all not super thrilled about saying that if you want to support web transport, you have to be willing to sign up for some amount of data. And the question was, are we okay to try to communicate that in settings and sort out what that means across different web transport sessions? Or does that make us barf a little bit and we'd like to find a better answer?
Lucas Pardue, I put a question in the chat. I don't think I got a response, or I missed it. But like, is settings the only frame-based communication of this number that we are considering, or do you want some web transport frame? Like, has that already been considered and discounted? I could understand why, but I just wanted to know.
So where would you put that capsule? Because you haven't opened the connect stream.
Frame.
Oh, so you'd actually put it as an H2 frame?
I mean, you've got to wait for settings. You could send that frame before the settings, you know, like.
Okay.
Well, maybe not actually in H2, but you could send it immediately
with the settings.
It would arrive in the same flight. Like I'm not saying that is the best option. It's just another in case you didn't want to. The settings thing was weird for some other reason that we haven't.
Thank you, though. I mean, I was assuming that would be a capsule, and it's a little hard to send that after on your Connect stream before your Connect stream exists. So this is much nicer. Okay, so this at least breaks you out of your single web transport session.
Yes.
Just somewhere other than settings. Thank you.
So I think the primary challenge here is from a performance perspective for the client and its first flight of data on each one of these Connect requests. So you make a Connect request and you would like to send some stuff immediately afterwards, and you can't send anything because without anything here, your stream limit is 0, your flow control limit is 0, your per stream flow control limit is 0, you've got nothing. Right? You can send a few sort of management-y things and open up the flow control for the server. So the server's not in any sort of bind, but the client is. And so having a way for the server to express maybe just the minimum stream limit and the minimum flow control limit across all of the services that it might serve would allow the clients to start doing real work before they got the status code back again. And so I think there's value to having that, but that only works if you have that before the client even makes the request in the first place. And so I think the only solution that really works for me here is settings. I don't really see much point in having additional frames because everything that we want exists in settings anyway. And we've got to send it. We have a way to change them in HTTP2, unlike in HTTP3, which would be a reason to use a frame. And it's relatively straightforward to understand how that they would apply in this context as well. So if we had, what have we got? 3 different stream limits and the corresponding amount of flow control limits, I think we're, it's a few numbers, but it'll be fine.
Session total data, stream within session.
Yeah, but you need to know streams of different types as well.
Fair.
So then
Plus each of your 3 friends.
Off it goes, right?
Yeah.
So there's 2 different flow control limits for the streams, 1 for the session, and 2 different types of streams that matter, right? So you have all those 5 settings that you could potentially pack in there. It's not a big deal. It's like, what is it, 6 bytes each or something in HTTP2. It's pretty efficient and would allow you to get out of that. And of course, the servers can go, well, I don't know what the backends I'm serving are capable of, and I'm not able to even get them to commit to allowing me to open 1 stream, so I'll just not send anything, and the defaults can be 0. So I think that works.
Which essentially makes this optional, and if you'd like people to not have to wait for you to send frames with your response, then you can send it in settings. And if you say, OMG, I'm an intermediary that serves so many different backends, I just cannot handle it, then you don't send anything and you wait to connect with each origin. And
accordingly, yeah.
David's gonna first as an individual contributor. Yeah, that sounds great to me. Now as chair, I'm feeling a sense of the room that this seems fine, good enough. Like that we put this in settings, and for cases where you can't, you don't, and for cases where you care, you do. Does anyone object to this resolution?
Give a thumbs up, you get a cookie.
Lucas gets a cookie. Martin gets a cookie. All right, good job. The cookies were outside, and if they didn't bring them, it's totally Eric's fault.
Oh, there's a bonus that comes with a cookie. You get to write a pull request.
Thank you, Lucas. All right, awesome. And this brings up set time. Thanks you, Eric.
Thank you.
And thanks everyone for resolving a rat hole in 7 minutes. We should have these deadlines more often. Thanks everyone for coming and for a very nice web transport session that was both productive and fun. And we shall see you on the mailing list. And we'll see based on how things progress whether we have an interim between now and July. But if not, hope to see a lot of you in person in San Francisco.
Okay, take care everybody.